All right, guys. So what we're doing today is dealing with figuring out how to find your solutions for an equation that the degree is too high for you to factor or solve in a way that you guys normally know how to. So we're going to come up with our possible rational roots. So it's possibilities that might work, and then we test those with synthetic division. If I'm doing synthetic division, how would I know if a number is one of the solutions or roots? What would you expect to find? Zero where? At the end. Yeah, so you would expect for there to not be a remainder, okay? So first we have to figure out how to come up with these numbers. So we're going to do what's called our PQ list. So your P is the factors of your constant term. Okay, so remember the constant is the one without any variable. And then Q is the factors of the leading coefficient. So you always have to make sure it's written in the correct order. Alright, so we're going to go ahead and make our P over Q list here. Alright guys, so P comes from the constant here, which is -6. What numbers can I multiply together to get -6? 3 and 2, what else?
6 and 1.
6 and 1. And do you guys agree that it could be -1, +6, +1, -6, right? Okay. So what we're going to do to account for that is write plus or minus, and then I'll just list all of those numbers. So those are all the possible factors of 6, -6. Okay? Over the factors of your leading coefficient. So our leading coefficient was 2. What are the only factors?
1 and 2.
1 and 2. Nailed it. Good work. What about -1 and -2? Does that work? Yes. Okay. So we still have the plus or minus. So every time you're going to have plus or minus in front. And then you have to actually make all the possible fractions you can out of these numbers. Okay? Please go in some sort of organized way when you do this. I like to go every numerator over the first denominator, and then do it again with the numerators over the second denominator. Have some sort of organized way. So plus or minus in front. 1 over 1 is 1. 2 over 1 is 2. 3 over 1 is 3. 6 over 1 is 6. And then I start over. 1 over 2, so that's a half. 2 over 2. Do you already have that? Yeah, that's just 1. I don't need that. So 3 over 2 I need. Do I need 6 over 2? No. Okay. So there is your list. These are the possible rational roots. So what degree was my equation here that I'm looking at? 3. So how many roots or solutions would you expect to have? 3. I clearly have way more than 3 numbers listed, right? So it does not mean these are the solutions. It's just they're the possibilities if there are any rational solutions. Do you guys know what rational numbers are? Somebody tell me. Describe a rational number. What'd you say? No, not going with it now. Okay. All right, these are all rational numbers, okay? 1, 2, 3, 6, 1/2, 3/2. They're numbers that you can write as a fraction, or they're a whole number. Numbers that are not rational, those are irrational, like square root of 2 or pi. Numbers that are non-repeating, never-ending decimals, we're not going to find those with our PQ list, okay? Imaginary numbers, we won't find those. But rational numbers, that's what these are, we could find those, all right? Please read directions. If all I say is find the possible rational roots, you make the list and you're done. You don't have to tell me which ones work. Don't do all the extra work, okay? So let's look at this little g of x function here. All I'm asking for is possible rational roots. That means make your p over q list. So let's do one more together, and then I'll have you try the next one on your own. All right, so remember, a numerator comes from the constant. So what's the constant here? What are factors of 2? 1 and 2, okay. Over, leading coefficient factors. So what are the factors of 8? 1, 2, 4, 8, good. Okay. So my list, I'm going to start with 1 over each of those numbers. So 1, 1/2, 1/4, 1/8, and then I'll do 2. So 2 over 1 is 2. 2 over 2 I already have. 2 over 4 I already have. 2 over 8 I already have. So that's it. Okay. Okay, you guys try the next one. I'll walk around and see how you're doing. Remember, you don't have to repeat them. If the fraction would reduce to something you already had, you don't have to write it again. It's kind of a long list. So factors of 6, 1, 2, 3, 6. Factors of 10, 1, 2, 5, 10. Lots of fun with number. All right. So I have 1, 2, 3, 6. 1/2. 2 halves I already have. 3 halves. 6 halves I already have. So that's 1/5. 2/5, 3/5, 6/5, and 1/10. 2/10 would be a repeat. 3/10. Okay. How'd you do? Yeah, just kind of annoying, but not really hard, right? Okay. What? You good? Okay. And you don't, the order doesn't matter. Like, I will check through how you wrote them. Just make sure you have all of them there. Okay, so there's not a specific, it doesn't have to be smallest to biggest, anything like that. You just have to have them all written down. Okay, so now what we have to do, now you have to use the possible rational roots and synthetic divisions to see which ones actually work. Okay, we're not doing it on that last one we just made the list for. Okay. This first equation here, we already did the P over Q list up above, so there it is for you. So now we have to check what's going to work. Do you think it's fun to start with the fractions? No, I don't either. So pick a number you want to start with. 1. All right, let's try 1. Do my synthetic division here. Bring down the 2. Multiply. Add. Multiply. Add. Multiply. Oh my goodness, look at that. We got a 0 as the remainder. Excellent first guess. What if you don't get 0 as the remainder? What do you have to do? Try again. Yes, try again. All right. Now, though, we have it down to 2x squared plus 13x plus 6. Once you get it to a quadratic, it's something that you should know how to solve. You can either factor or use the quadratic formula. What do you think? Can we factor? Yes, it factors. When you're ready, when you have it factored. Okay, so once I'm here, I need to actually solve and find all the roots. So what are my answers? What does x equal? Yep. Okay. Now it was third degree, so I should expect one more solution. Yes, it's 1. Don't lose this guy over here. Okay, the one that worked with your synthetic division you need. Do you guys notice that all of those numbers are in your P over Q list? Okay. So if you had picked any of those for synthetic division, it would have worked. Just all right, so let's try again. So this next one, first thing you have to do is determine the possible rational roots. That's the P over Q list, okay? Then determine the zeros. That's the whole using the synthetic division part. Figuring out what works. We're solving, okay? So I'm going to give you a few minutes. Start with your list. Okay, so if that confused you yet. No, it won't be a group effort simply as you can just like yell out, hey, breathers. Make your list for you. All right, guys. Okay, is everybody okay getting to the 3x squared plus 4x minus 4? Okay, and then it's just a matter of factoring from there. Right there. 2 minus 2 plus 2. Yeah, that works. All right, so my answers. I get 2/3. I get -2, and then again, don't forget that guy, the one that you used in your synthetic division. Just take a second, double check at the end. Does the number of answers match the degree of your equation? So you know you didn't forget to write anything down. All right, okay? Questions so far? Wait a sec, make sure everybody's caught up. Page, guys. Okay. Look at all this. All right. let's look at number 1 up here together. And clearly I've crossed out number 2 and I've rewritten number 3. So hopefully you didn't work too far ahead on me. Number 1 is not written in the right order. So you want to make sure that you're looking at the correct constant and leading coefficient when you do this. So we'll rewrite it in order, but then what else do you notice about this one? It's long. Yes. It's what? Sorry. The degree is 4 now, okay? So how many answers do you think we should get at the end? 4, okay. And we won't be able to do just one round of synthetic division. So let's go through this one together. I'm going to use the space over here by the 2 because I'm not doing that guy. So let's make our P and Q list. So my constant is 8. 1, 2, 4, 8. Leading coefficient? 1. That's handy, right? Okay, so that's it. That's your list of P's and Q's. Okay, what do you want to try first? 1? Okay, let's try 1. 1, 2, -5, -2, 8. Multiply, and multiply, and oh, look at that, we got a 0. So nice when you find it on the first one. Okay, once we're here, what this means though is that I now have x cubed plus 3x squared minus 6x minus 8. That is not a quadratic yet, which means it doesn't factor nicely in this case. You can't use the quadratic formula. Like you can't solve it yet. So what do you think I need to try from here? Synthetic division again, but with these as your new coefficients. Okay? You don't need a new PQ list, you just pick another number. So what do you guys want to use? 2? 2 sounds like a great choice. Multiply and... Okay. All right, are we getting to that 0? Stop me if I go too fast for this, guys, okay? Okay. 154, what is that actually, like what do I have now? Good. We divided twice, so now we're down to a quadratic. And is that something we know how to work with?
Yeah.
Yeah, we can factor that. What does that factor into? Alright, so my answers, I know I have -4 and -1, but remember I'm supposed to have 4 answers, so what are the other 2? 1 and 2, good. Okay. So it's not that much worse, you just have to do your division again. Alright, so you guys gonna try number 3 for me. Same idea, I rewrote it here. I'll move it up so you can see it. 4th degree again, so you're going to have to do 2 rounds of division. this one, don't forget that PQ list. Remember, it's plus or minus all of those numbers. Yeah. How many people?
Let's just go with 2. But it didn't matter how many I have, there will always be 1, 2, 3, 4 possible. You might
So did you get the first one?
Does it have batteries?
This one doesn't work, but I took one extra. But of course, then I get it back here, I guess what's actually Casey. You know, I'll take one from you too. Just so I can get downstream.
Do you want like a nicer one?
Yeah.
That looks really nicely decorated. I have no idea if they have batteries or
I had
anything.
this, I had this.
Are we still surrounding with this? Yes. Open this.
I'll get it by next class. Yes, Jenny.
Super quick lesson on it. Hey, that's, you know, perseverance. That's what we like. All right, guys, let's go through it. I think you're good at making your P&Q list at this point. So let's see, did one worked, right?
Yes.
Yes, okay. Okay, and then -1? Yes, is that right? Okay, so I get to this 2x squared plus 7x plus 3. Right? That factors. Let's do 1, right? Okay. All right, so I get -1/2, -3, and then what else? Both positive and -1, right? Fourth degree, 4 answers. Looks like it's going how it's supposed to. Did you guys figure out? I don't remember which of you wrote what, but we agree now. Okay. All right, any questions on that one? Take your time when you're doing your synthetic division, because if you screw up one of the ones that works, that's, you know, not real fun. Yeah, it's going to take you a while, so take your time. On a quizzer, you know, your assessments with this, I would never give you one that has like 30 possible P over Qs for you to try, okay? I will make it reasonable. It won't be terrible, so. All right, so do we feel okay with the whole synthetic division, finding roots, all that stuff? Okay. All right, imaginary numbers. You can see this is written down below here. Okay, couple things with imaginaries. First, you guys remember them from last year? A little bit about them? Okay, what does I actually equal? Square root of -1, yes, okay. Do you remember anything about solutions that were imaginary? Can they be alone? No, they always have like a partner, right? So if I have positive 2i, even though it's not listed, I know that negative 2i is also one of the solutions, okay?
Vice versa.
Yes, yep. Okay, then to write a polynomial with these solutions. So think about up here, like if my solution was -3, I had a factor that was x plus 3, right? Okay, so I've given you the solutions, you have to go backwards and write the factors. So the first solution you have there is -3. So what is my first factor? X plus 3, good. Okay, your next solution is 4. So what's your factor? X minus 4, good. Okay, then I have a positive 2i, so what am I going to write? Well, okay, eventually, but like writing them out separately, what's the first factor going to be? Good, x minus 2i. And then what's my last factor going to be? X plus 2i, good. Okay, so that's how we write our factors. No, you do not have to multiply everything together here. You have to multiply just enough to get rid of the imaginary numbers. Okay? So do you think I need to multiply the x plus 3 and the x minus 4 together? No, I can leave those alone, so that's part of my answer. And do you guys notice I'm writing y equals every time? Please do that. Or f of x equals. It's not actually an equation unless you have that. So, all right. But I do need to multiply this x minus 2i and x plus 2i. If you want to go to the side and do box, that's fine. If you can just FOIL, that's great. I don't care. It's like factoring. As long as you can do it correctly, I don't care what your method is. All right, so x times x, x squared. Then I get plus 2xi minus 2xi. And then minus 4i squared. So what's going to happen to the 2xi's? They cancel. Guys, that should happen every single time. That's why they come in pairs like this. That's what the conjugate does for you, is that's going to eliminate. You're not going to have those imaginaries anymore. And then we need to remember, what does I squared equal? Oh, good, you guys. So this is really -4 times -1. So what does that really mean? 4. Yeah, so your answer is y equals x plus 3 times x minus 4 times x squared plus 4. Okay, questions on that one? All right, that one is not too bad. This one is a little longer. I'm going to write it down below just so that I have enough room. Okay. So this time we've got our -1, 5. Those are easy. I have 3 plus I. Any guesses as to what the pair that's going to go with that one is?
Plus I, minus I.
Yes, exactly. It's the sign in front of the I that is the one that's going to change. So you're not given that one, but you know it is there. So 3 minus I is your other solution. Okay? All right, now let's think about writing our factors. Okay, your first solution is -1. What's your factor? X plus 1, good. Next solution's 5. Okay. All right, this is where it gets tricky. In every single one of these, you have done X and then minus the solution, right? Okay, so let me write that with extra parentheses for this one. So we're going to do X minus the whole thing, 3 plus I. Now, you're not going to need to write it this way every time, but I want to make sure you see what's actually happening. And then my next parenthesis, I'm going to have X minus the whole quantity, 3 minus I. All right. Does that make sense, what we're doing? Okay, it's really easy to mess up the signs here. I don't want you to do that. So that's why we're writing it this way. So again, I'm leaving alone X plus 1, X minus 5. Let's write this without quite so many parentheses. So the first one, I'm going to have the X. What's the rest of it going to be? -3 and is it plus or is it minus I? Minus. You have to distribute that negative all the way through. So it's X minus 3 minus I. And then what's your last group going to be? Say it again, sorry.
X minus 3 plus I.
Perfect. X minus 3 plus I. There we go. Okay. All right. Again, multiplying, and there's a couple different ways we could multiply this out. I'm just going to go through essentially foiling, even though there's more than one or more than 2 terms. If you need your box to keep it organized, that's fine. Whatever you need to do. A lot of things are going to cancel after we start multiplying. So I'm going to take X times X, which is X squared. X times -3, so minus 3X. X times I, which is Xi. Okay. Then I move on to the -3. So -3 times X. -3 times -3. So plus 9. And -3 times I. Minus 3I. And then your last one. I know I've got lines going everywhere now. So -I times X. Minus Xi. -I times -3. Plus 3I. And your last one will be minus I squared. All right, I know that's ugly. It'll get prettier, I promise. Does everybody feel okay with multiplying that out in some method? I don't care which method you use, but are we okay multiplying? Okay. All right, what is going to go away here? The xi's are gone. What else? 3i's, yeah. And what does minus I squared actually become?
1.
plus 1, right? Okay. So you can combine some like terms, and we'll write our answer here. All right, so x plus 1 times x minus 5. Then I'm going to have x squared minus 6x plus 2. Okay, again, don't multiply more than that. I don't want you to do any other multiplication. Questions on that one? Okay, we're going to try one more of those just to make sure you've got it with all the signs. I want you to do one on your own. So find somewhere on your paper to jot it down. Anybody need more time on this one? That. All right, let's say your solutions are 7 and 2 minus I. All right, guys, let's look at this slide. Okay, so we're fine starting with x minus 7. Everyone's good with that. Okay. Then it's x minus the whole quantity. Again, you don't have to write this step as long as you're not messing up your signs. Okay, so x minus 2 plus I and x minus 2 minus I. Those are the two things I have to actually multiply together. Whatever way you get there. Okay, xi's gone, 2i's gone. And what is minus I squared? Plus 1. Yes. So your answer should be x squared minus 4x plus 5, and that x minus 7. Walking around, it looked like quite a few of you got there. How many got there? Yes, makes sense. Okay. Any questions over what we did today? Okay, homework. Let's just do odds. And there are definitely some that will not factor. So you'll go through and do your P over Q, find one that works with synthetic division, and then you may have to do quadratic formula after that if it doesn't factor. Okay?